seen how graphical methods can be cumbersome if we're dealing with high dimensional problems. And before we're going to go on to Gauss elimination techniques, we need to look at determinants and Cramer's rule. So Cramer's rule is also another method you could use to solve a set of linear algebraic equations, but it's best suited to small dimensions. So in order to use Cramer's rule, we're going to need to develop an understanding or review our understanding of determinants because it's required. So for example, if we had the following algebraic system, so matrix A multiplied by vector x being equal to a set of constants B, where A is equal to the matrix A11, A2, A12, A13, A21, A22, A23, A31, A32, A33, then we would write the determinant D being equal to straight line bracket A11, A12, A13, A21, A22, A23, A31, A32, A33. Now, immediately you notice that the determinant has a similar composure to our matrix A, where the elements are the same, but it is a completely different mathematical concept. And that is, the determinant is calculated as D being equal to A11 multiplied by the minor A22, A23, A32, A33 minus the element A12 multiplied by the minor A21, A23, A31, A33, and we mustn't forget our element A13 multiplied by the minor A21, A22, A31, A32. Okay, so you would have heard me talking about this term next to each element as a minor, and that is also a determinant, which is calculated as A22 multiplied by A33 minus A23 multiplied by A32. Okay, just remember that because it's going to become important later on. Alright, so now on to Cramer's rule. And Cramer's rule states that each unknown in a system of linear algebraic equations may be expressed as the fraction of two determinants with the denominator D and the numerator obtained from D by replacing the column of coefficients of the coefficient of the unknown in question by the constants. So what this means is, in a two-dimensional system, if we wanted to find x1, we would take the numerator, which is obtained from the determinant of our matrix A, and we would replace the first column with the constants. So that would be B1, B2, A12, A22, divided by the determinant of our two-dimensional system, which is A11, A12, A21, and A22. And then all we would do to calculate x2 is replace the second column. So it would be in our numerator. So it would be A11, A21, and remember we're replacing the second column, so it'll be B1, B2 divided by our determinant.